Problem 133. A certain country had a total annual expenditure of 1.2 times 10 to the 12th power last year. If the population of the country was 240 million last year, so the population is 240 million, what was the per capita expenditure? So 240 million, what is that? That's a million is 10 to the 6th power, right? So this is 240 times 10 to the 6th, right? And that's the same thing as 24 times 10 to the 7th, right? I just took 10 from here and multiplied 10 there. And that is equal to 2.4 times 10 to the 8th power, right? Divide this by 10 and multiply this by 10, you get the same number. So 2.4 times 10 to the 8th. So the per capita income is going to be equal to the total annual expenditure, so 1.2 times 10 to the 12th, divided by the population, 2.4 times 10 to the 8th. Let's see, 1.2 divided by 2.4, that's equal to 0.5, right? That's exactly half of that, times 10 to the 12th divided by 10 to the 8th. You just subtract the exponents, that's 10 to the 4th. And that's not one of the answers, so we could write this as, so we could multiply this times 10 and divide this by 10. So this becomes 5 times 10 to the 3rd. 10 to the 3rd is 1,000, so 5 times 1,000 is equal to $5,000, or 5,000 whatever, yeah, dollars in annual expenditure per capita. And that's choice E. Problem 144. 134, sorry. A certain rectangular window is twice as long as it is wide. So twice as long as it is wide. So if this is the width, its length is 2 times the width. If its perimeter is 10 feet, then its dimensions are, so its perimeter is going to be w plus the two lengths, right? So its perimeter is going to be 2w plus 2w plus w plus w, and that's going to be equal to 10. If we add up all the w's, that's 2, 4, 5, 6. So we get 6w is equal to 10. W is equal to 10 over 6, which is equal to 5 over 3. 5 over 3 feet. And so its dimensions are 5 over 3, and then the 2w, so the length is 2 times that, which is 10 over 3. So it's 10 over 3 by 5 over 3. And that's choice B. They say 5 over 3 by 10 over 3, but same thing. So choice B. Problem 135. 135. Okay, interesting. Let's see if I can draw this diagram. So we start, this is x, and then it goes there. It has a diamond like that. And it goes like that. Then we have another diamond. Let's see. I don't know what this is all for yet, but it looks interesting. It goes like that. Then it goes like that. There's a diamond there. It's like there. There's a line. Goes like that. It goes like that, and like that. And then finally, we're at y. The diagram above shows the various paths along which a mouse can travel from point X where it is released to point Y, where it is rewarded with a food pellet. How many different paths from X to Y can the mouse take if it goes directly from X to Y without retracing any point along a path? So let's see. There's only one way. It has to go here. So we are only at one path right now, one path. And then it can either go this way to get here, or it could go this way, right? So to get here, there's how many different paths? Like that or like that. So at this point, there's two ways to get right there. There's one way to get here, 2 ways to get here. Now, there's 2 ways to get here. That means that there's 2 ways to get here. Now, how many ways are there to get here? Well, there's each of the 2 ways to get there, and now we have each of those in combination with each of these 2 ways. So there's 4 ways to get here. You could think of it like this. You could go the top one and the top, that's 1. Top and the bottom, 2. Bottom and the bottom, 3. Bottom and the top, 4. So you could just multiply how many ways to get here, and then how many more ways to get from here to here, right? From here to here, there's 2 possible ways, and there's already 2 ways to get here, so you could multiply the 2. So there's 4 ways to get here, 4 ways to get here. To get from here to here, there are 3 ways, right? 1, 2, and 3. But since there are already 4 ways to get here, for with each of those 4 ways, we can go in 3 different ways. So we multiply 4 times 3, there's 12 ways to get right here. If there's 12 ways to get here, there's 12 ways to get to y. So the answer is C, 12. Problem 1, 136. If the operation circle with a dot in it is defined by x circle with a dot, y is equal to the square root of xy for all positive numbers x and y. So they're saying x and y are greater than 0. That's good because that ensures that we have a positive under the square root sign. Then they want to know what 5 circle with a dot 45 circle with a dot 60 is equal to. Well, 5 circle 45, that's equal to the square root of 5 times 45. Right? That's that. And whatever that is, we're circling with that, right? So what you do when you have circle x circle y, you multiply the 2 and then you take the square root. So we would multiply 60 times this and take the square root of the whole thing. So you would multiply, so let's see. Well, actually, let's just simplify this. This right here is equal to the square root of 5 times 45, which doesn't look simplifiable at face value, but if you think about it, 45 is 9 times 5. You just want to take out any perfect squares you have there. So that's equal to 5 times 9 times 5, and that's equal to square root of, what, 25 times 9. And that is equal to the square root of 25 times the square root of 9. And that's equal to 5 times 3, which is equal to 15. So this simplifies to 15. And 15 circle, dot circle, whatever you want to call it, 60, is equal to the square root of 15 times 60. And let's see if we can somehow turn this into some type of a perfect square. Let's see, 4. Yeah, let's rewrite this as 15. 60 is the same thing as 15 times 4, right? So this is equal to the square root of 15 times 15 times the square root of 4. The square root of 15 times 15, well, that's going to be 15 times 2, which is equal to 30. And that's choice A. Problem 137. I'll do it in yellow. Problem 137. A bar over a sequence of digits in a decimal indicates that the sequence repeats indefinitely. What is the value of 10 to the 4th minus 10 to the 12th times 0.0012, and then this 1, 2 will just keep repeating over and over again. So let's see what we can do. So what's 10 to the 4th? Well, let's think about it this way. Let's distribute this, right? So what's 10 to the 4th? That's 10,000. So what's 10,000? 10,000 times this number, right? Well, let's 0.0012. So the easiest way, and this 1, 2 keeps repeating, so we'll think about that in a second. So what's 1, 2 times 12? What's 12 times 10,000? What's 120,000, right? 120. It's 12 with 4 zeros through 3, 4, right? Which is 120,000. We have 4 numbers behind the decimal point, so it gets us there, right? You might say, okay, we're done. It's 12, but it's actually not 12 because it's actually 1, 2, 1, 2, 1, 2. The 1, 2s just keep going. So it would actually be 1, 2, 1, 2, 1, 2, and then 1, 2s keep repeating on like that, right? Fair enough. I think you understand why, right? This would be if we just had one 1, 2 times 10,000. But if the 1, 2's kept going, then these wouldn't be zeros. These would be 1, 2's, right? Hopefully that makes sense to you. Maybe there's an easier way to think about it. And so what's 100? We'll use the same logic. What's 100 times 0.0012? Let's see. That is, well, actually, I could probably get on this a simpler way, but let's just continue this way. So 12 times 100 is 1200. And we have 4 numbers behind the decimal point, right? 1, 2, 3, 4. So 1, 2, 3, 4. And of course, it's not just 0.12. It'll just keep going. 0.1212. It'll just keep going, right? So we have this times this, which is this, minus this times this. I'm just distributing it. So if I just subtract this from that, minus 0.12. Oh wait, no. I wrote this right. This was 12, right? Because we said 12 times 10,000 is 120,000. We had 1, 2, 3, 4 behind the decimal. 1, 2, 3, 4. So it's 12, right? But since we had multiple 1, 2's behind it, it becomes 12.12. I don't know what I was doing with this right here. So the answer, so let me write that again. I'm sorry, I'm doing this one a little bit messy. So 0.0012 repeating times 10 to the 4th is going to be equal to 12.12 repeating. And we're going to subtract 0.0012 repeating times 10 squared, and that is equal to 0.12 repeating. So if I subtract out the 0.12 repeating from 12.12 repeating, I'm just going to be left with 12. And hopefully that's one of the answers. It is choice E. See you in the next video.